Hi guys, you're welcome to my channel. All right, today we're going to discuss about automation skill set. You know, for the benefit of those my followers and my friends who are asking for automation requirement before they want to embark on the automation skill. So my regular response to them and my advice to them has always been control system perspective. You must have to come from control system perspective before you go to automation. The reason for that is that control system will enable you to familiarize yourself with what we call relay logic and also use relay logic to control a process operation. Example is this: if I want to design a panel, to control my door, I have to put up a schematic that will do that logic. So that when you come close to your door, you approaches your door will open. You gain access to your premises. Then the door closes back. That is automatically relay logic control. All right. Understand the functional procedures and the operation sequence of a particular process, and also do the panel building. Build the panel to control that process before he now said, okay, let me use a PLC to control that same process for more efficient and more precise manner. That is what PLC does. Now, that is the step one. You must familiarize yourself with relay logic. Now, step two is what you need to understand the objectives of PLC. Why do I need PLC? What are the advantages of PLC? So you now know that if I want to design a panel that require the services of a PLC, I will do that. Otherwise, I'll use other miniaturized controllers. We have a lot of controller that does process control, that is not PLC. But PLC now is the more advanced way of controlling a process, and it will give you precise operation and also cost effective for that operation will also be gained. And it will also efficiently drop and drastically drop the manpower operation. Reduces the operation of individual control. It will take over control of individual activation process. So you must understand these two steps: why you need PLC and the advantage of using PLC. Having gone through this, you now come to step three. Step three will allow you to understand the configurations of PLC, the software configuration and hardware configuration. You need these three steps before you enter the automation. Then step four, you must also understand the HMI. You must register the HMI configuration and the PLC, how to write program for PLC and how to write program for HMI. Understand this first step before you embark on PLC career. This three step is something you can do without going into automation. When you are done with this, you now go into automation proper by registering number four. Number four is to register the PLC and register the HMI. Understand the two first, because the most challenging aspect of automation is your ability to understand field devices. What are field devices? Relays, contactors, timer relays, and sensors, and input devices and output devices. Your ability to understand the configurations of these the components and they configure them to perform a particular task. That is the most challenging aspect of automation. Automation, writing program with your PLC, your software, is the simplest aspect of automation. The most difficult aspect is for you to understand the functionalities of the process you want to embark on, the process you want to control. The process of getting system energized and getting the operation done by sequential logic. Some people will know how to write a program and download to PLC, but when the fault arises in the field, troubleshooting the fault becomes a major task to them. And that is where I want you to familiarize yourself to before you write a program. Even if you are not good in writing program, in writing code, that is not a big deal. but you know the process operation of what you want to design or you want to install. Now, you can also employ the services of an expert who does the code very well, who write the code. You pay the person to write the code. He now gives you the code, the soft copy. All you need to do, download the code into PLC, then continue your installation of your few devices. You know, that is best. But I am not advising you or proposing for you not to write the code yourself. You must do that. In fact, that is the basic, that is the beginning of your automation career. You must know how to write PLC. But what I'm saying is you must understand what you want the PLC to do for you. The field, the process operation you want to embark on. You must understand the process. How do you understand the process? By understanding logic, relay logic, how to use timer, contact, sensors. You must understand sensors. Very, very important. Understand sensors and configurations of sensors. Understand timers and configurations of timers. Understand relays. Understand contactors. Understand switches. How do you know them? You must understand them by going to relay logic. This is a relay logic. Okay, for instance, let's control this. Let's control this. I want to control this load using timer. Okay, let me simulate that. Now I have this process in two versions. I have the wiring of the 3D so that I can visually see the composition of the component you want to work with. You have them in 3D here and you have this in 3D as well. Then I have the schematic in this portion. This schematic will enable you understand the design aspect. You must understand the design perspective first. You now know how to do the wiring. If you don't understand the function of this, wiring this will be a very tasking, challenging task. All right. So let's simulate this. Let's simulate this. Now, the idea behind this is this. I want this load to come up and shut down after preset time. And this timer will do that for me. All right. So I put on the load. Look at it on. It will shut down after. Thank you. It will shut down. Let me now set this. Let me further increase this to 5 seconds. So now this load will shut down after 5 seconds. The same thing is applicable to this place. This one is this is for the wiring to enable you know the physical structure of the component. So this is how you do the wiring. Then the design is this is schematic and this is the wiring diagram. Right now let's go to PLC and do the same. Okay, this PLC. Now this is my PLC. This is timer. This logic is the same way. Once I activate this logic, this load will come up and this load will shut down after preset time by the timer. Okay, can we see if we can also simulate this in a short while? Let's simulate this. Just hold on, let me put it on. The simulation system will come up. All right, now I want to put on the load. I want to put it down. It will come up and shut down after a short while when the preset time elapses. Okay, let's do that now. I put on, the load is up. Motor 1, motor 2, motor 3, they are running. They will shut down after a while. Now, you see that shut down. The same timer I use to control this load. So this is software for automation. Then this other software, sorry, for my schematic, this is for control. This software is for control system. This software is for control system. So the same way I control my logic using control logic is the same way I use PLC. Difference between them is that PLC is more efficient method of controlling a process and the cost effective, but it's very expensive purchasing PLC where you want to control electro process. So we also have other modular controller, smaller controllers. So that's why I said you must understand what you want to design. I just show you PLC and I also show you control system. So this is control system. Then let's come back to our narrative. Now, I say you must, step 2, understand objectives of your PLC. Why do you need PLC? Now, having known how to design your logic control, he now enclose them in a panel and he want to use them to control a process. He now